The next part of this course, the last part of this course, is looking at sequences in series. Sequence is just a list of numbers in a set that have some sort of pattern. And so, for instance, let's say that, in set notation, you do use these, what I call curly brackets. So let's say that S of n, this is equal to the set n squared plus 1. So if I were to look at, basically this is just like a function. S of n is just like a function, but the values we plug in for n are our whole numbers. So if I wanted to find the first term, how I would do that is I would plug in 1 wherever I saw an n in this n squared plus 1. So S of 1, all that is equal to 1 squared plus 1. So this is equal to 1 squared is 1 plus 1, which is 2. This S of 1, this 2, this is the first term in our sequence. Okay, so second term, and the directions in this one said list the first 5 terms of the sequence. So to get the second term, what we're just going to do is look at S of 2. So we're going to go back in to the formula and we're going to plug in 2 wherever we see an x. So we get 2 squared plus 1. Well, 2 squared is 4, 4 plus 1 is 5. So that's the second term. Third term, we're going to just plug in 3 wherever we see an n. So we have 3 squared plus 1. And so 3 squared plus 1, that's 9 plus 1, so that's 10. S of 4, so just plug in 4 wherever you see an n. So we have 4 squared plus 1 is 16 plus 1, which is 17. And the last term of the 5 terms it wants us to list out is S of 5, plugging in 5 wherever you see an n, you have 5 squared plus 1, so 25 plus 1 gives us 26. So the first 5 terms of the sequence we can list as 2, 5, 10, 17, and 26. And that would continue to go on forever. So again, these are kind of like functions. So for instance, let's say that you have the example where, how about, let's call it C sub n. And C sub n, that sequence is defined to be -1 to the n plus 1 power, and then times n squared. And again, it wants us to find the first 5 terms of the sequence. Okay, so same idea. First term, you're going to plug in 1 wherever you see an n. So C sub 1, the first term is going to be, in this case, -1 to the 1 plus 1 power, all times 1 quantity squared. So this gives us -1 squared, which is +1, times 1 squared, which is +1. 1 times 1 is 1. C sub 2 plugging in 2, wherever we see an n, we get -1, 2 plus 1, all times 2 squared. So -1 cubed is negative. -1 times 2 squared. 2 squared is 4, so this is -4. You'll notice that our terms are going to start alternating between positive, negative, positive, negative. And that's because of how they wrote this exponent. And there's going to be times where you look at a list of the terms and then you try to figure out how can I define the nth term of that sequence? What formula can I use? And if it's alternating in signs, then that should clue you in to use -1 raised to either the nth power or n plus 1 power, depending if you wanted to start with a positive number or a negative number. Okay, so C sub 3, plugging in 3 wherever we see an n, we get -1 to the 3 plus 1 power, all times 3 squared. Well, 3 plus 1, that's 4. So -1 to the 4th power, that's now +1, times 3 cubed is 9. C sub 4, well, I'm going to get -1 to the 4 plus 1 power. So that's going to be the 5th power, all times 4 squared. So this is going to be -16. So I can see that these are squares: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, which would be 25. And it would change to a positive because the last one was negative. 5 plus 1 is 6 power, and we have 5 squared. Okay, so our terms, first 5 terms of our sequence are 1, -4, 9, -16, and 25. Okay, so this was the start. We haven't gotten through even the first section yet on sequences and series. We're going to get into the next 2 sections. Last 2 sections are just special sequences, which are arithmetic sequences and geometric sequences. But we're going to stop here for now, and we'll pick this up either Tuesday next week or the following week.